Hi there, this is Penelope. This is topic 6, class 4. We are still looking at functions, but at the moment we're looking at logarithms. And we introduced the idea of logarithms in the previous classes. So, just like everything else, there are rules that govern how these things work, and let's look at them. The first rule is how we deal with multiplying logs. And the rule is that the answer is log to whatever base you're working with, x plus log to the base b of y. And that kind of makes sense when you think of the relationship between powers and logs. So if you've got x to the power of a times x to the power of b, the answer is x to the power of a plus b. It's kind of the same answer here. Similarly for division, the division of a quotient is log bx minus log to whatever base y. This corresponds to x to the power of a over x to the power of b is equal to x to the power of a minus b. The last one is log to any base of x to the power of n will equal n log to any base of x. That corresponds to x to the power of a times b when you multiply the powers. Oops. So x. Now, these rules are true for any base b. You're given them in a test or an exam, or you can take them in on your cheat sheet. Does make sense if you learn them, it's much quicker. In this course, we don't need to prove them. You are just told these are the rules. Well, let's have a look at how we can use them. Log 4x squared plus log 3x. Because it's plus, we can then multiply the bits. So that's log of 4x squared times 3x. So it's equal to log, whatever base we're talking about. 4 3's are 12. X squared times x is x cubed. The next one, because it's minus, is a division. So it's equal to log of 5x to the 4 over x, which is log 5x cubed. Next one's a little bit more complicated. It's got multiplication indicated by the plus and division indicated by the times. What I do is I just set it up in the whole thing and I start left to right. I know it's going to be multiplication and then division, so I just start log. Now I know that there's a division, so I may as well put my division sign in. So on the top for the multiplication I've got 5x squared times 4x, and then for my division I've got 10x squared, and when I simplify that, that's log 20x cubed over 10x squared. So that becomes log, cancel, whatever, 2x. The next one has got a power as well as division. So let's do the first bit first. It becomes log x3 cubed minus log x squared 4. So that's log x to the 9 minus log x to the 8. Now we've got a straight out division sum, so we can go log x to the power of 9 over x to the power of 8, which is just log x. Much more simple. Now, there's no point in learning about logs if we can't actually do something with them other than just straight out simplifying. And the big thing we can use them for is solving equations. Now, just a little trick to remember. If you've got e, then use natural logs. Use log to the base e. If you don't have e, then you can use whatever base you like. You can use 10 or you can use e. But the thing to do is to turn it into a linear equation and solve that. So the first one, what we do is we take the logs of each side. So we take log 2 to the x equals log 7. Now remember, we're just solving an equation, so we can do what we like. We can take logs of each side, but now we've got a rule that we can use to bring that down here. So it says x log 2 equals log 7. And the fact that we haven't got a number there implies that it's base 10. I don't need to write it in. So that now, if I rearrange that, I say x equals log to the base 7 divided by log to the base 2, which is not the same as what we were doing on the previous slide. Go back and have a look and see how it's different. Now it's a calculated job, so we'd put that in the calculator and we'd get that the answer is approximately 2.807. For the next one, as I said, we're going to take the natural log of each side, except that we need to deal with this 3 first. So we can divide each side by 3, then we've got e to the x minus 1 equals 75 over 3. 75 over 3 is 25. Now we can take the natural log of each side. Now we can bring the power down to the front. And this is where it becomes so easy, because natural log of e is 1, because what that's saying is what power of e is e, and the answer is 1. So now we can say that x minus 1 equals natural log 25, so x equals natural log 25 plus 1. Now just be careful, it's not natural log of 26, it's natural log of 25 plus 1, and you'd need to then look that up on your calculator. Natural log of 25, close your brackets, make sure you close your brackets, plus 1 is 4.21, or make it 4.219. Check your answer to see if that's right. The last example here is slightly different, and it's quite difficult, but it becomes a whole lot easier if you remember what you're doing. This implies multiplication. So it's log x plus 2 times x minus 2 equals 1.3. Now, because there's no base specified, we can assume that it's a 10. So we can take 10 to the power of all of that. Because 10 kind of undoes, it doesn't cancel, but it kind of undoes that. So we're now left with, oops, not much room. So now we're left with x plus 2 times x minus 2 equals 10 to the 1.3. The left-hand side is actually one of those special things. It's x squared minus 4 equals 10 to the power of 1.3. So x squared equals 10 to the power of 1.3 plus 4. And x equals plus or minus the square root of 10 to the power of 1.3 plus 4. I've run out of room, but you can look that up on your calculator. The last thing to look at is the graph of a logarithmic function. I've got there on the screen log x, which is log to the base 10 of x, and natural log of x as well. As x gets bigger, so as we're going that way, the values of both of those logs get bigger. We also can see that log of 1, log to the base 10 of 1 is equal to 0, and natural log of 1 is equal to 0 as well. What we also find is when we're going back to the left, so as x approaches 0, then both of them, both natural log x and log to the base 10 of x, get very negative, so they approach negative infinity. When x is less than 1, so here, when x is less than 1, the values of the log x and natural log x are negative. But what we do find also is that nothing exists over here, because log x and natural log x of x are not defined when x is a negative number. And we looked at that right in the very first video on logs.